Today we're going to talk about how we can complete a table given a function and then plot those coordinate points on a coordinate grid. So today we're going to be working with the function y equals negative 2x plus 3. And we have our table with a couple given x values and a few given y values that we want to be able to use our function to figure out all of the missing values to complete our table and then to plot the coordinate points on our coordinate grid. So first let's begin looking at our first x value, negative 3. What we can do with this value is plug negative 3 into our function y equals negative 2x plus 3 and evaluate that function for y. So if we replace the x with a negative 3, we get y equals negative 2 times negative 3 plus 3. Now, in order to solve for y, we want to use order of operations. We want to make sure that we are doing multiplication first. So we know that negative 2 times negative 3 will give us a positive 6, and then we still have to add 3 to that. 6 plus 3 will give us 9. So for our function, when x equals negative 3, our y value is going to equal 9. We can do the same sort of pattern if we know that y equals a positive 5. We can plug in 5 for our y value. So we have 5 is equal to negative 2x plus 3. But in this case, we want to be able to solve for x. We want to know what that equals. So we're going to go ahead and draw our line straight down from the equal sign. And we want to think about how can we get the x by itself. So we're kind of thinking about this as backwards order of operations. So we want to know if there's anything we could add or subtract to the other side to get the x by itself. And in this case, we're going to be able to subtract a 3 from both sides. So 5 minus 3 will give us a positive 2. Our 3's cancel out on the right side, so we are left with a negative 2x. Now, whenever we have a number right next to a variable, that operation is going to be multiplication. So we can think of it as having a multiplication sign in between those. And we also know that division is what undoes multiplication. So we want to divide both sides by negative 2. On the right side, our negative 2's cancel out, and we are just left with x. And on the left side, positive 2 divided by negative 2 is going to equal a negative 1. So when the y value is 5, using our function, our x value is going to be negative 1. We can continue this pattern for the rest of our points. So when x is 0, we'll plug in 0 into our function for x. So we will get y equals negative 2 times 0 plus 3. And once again, using order of operations, we'll do multiplication first. Negative 2 times 0 is 0, plus 3, so y equals 3. Our next value, y, is going to equal negative 1, so we're going to plug in negative 1 for the y value. So we have negative 1 equals negative 2 times x plus 3. In this case, we're going to have to solve for x. So once again, we're going to subtract 3 from both sides. Negative 1 take away 3 is going to result in a negative 4 equaling to 2x. And then we can divide both sides by negative 2. So on the right-hand side, our negative 2's cancel out, and we're left with just x. On the left-hand side, negative 4 divided by negative 2 is going to result in a positive 2 value. And then for our final point, we're going to plug in negative 5 for that y value. So we have negative 5 is equal to negative 2 times x plus 3. And once again, since we want to get x all by itself, we're going to have to set up a solving problem in order to solve for x. So we will subtract 3 from both sides. Negative 5 minus 3 is going to result in negative 8. It's equal to negative 2 times x. To undo multiplication, we will have to divide. We have negative 8 divided by negative 2. It's going to result in a positive 4. Our negative 2's cancel out on the right side, so we are left with just x. So when x is positive 4, y is going to equal negative 5. We can also double check this by plugging in both values to make sure they equal one another. So we can always double check our work. All right, so now to plot the coordinate points, our first one is going to be negative 3, 9. So we're going to go negative 3 on the x-axis, and note that our x-axis is the one that runs horizontally, and our y-axis is the one that runs vertically. So we want to move over to the left 3 spaces, so 1, 2, 3, and up 9 spaces. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and we're going to plot our point